Hello everyone, it's indeed inspiring to tell you that we are back again with another concept which is known as a priori algorithms. Starting with the history of a priori algorithms, this algorithm was introduced by R. Agrawal and R. Srikanth to Indians in 1994. Now before discussing the concept of a priori algorithm, let's just discuss this story of vegetable seller. Kamla, the vegetable seller, always bundles onions and potatoes together. She even offers a discount to people who buy these bundles. Why does she do so? She realizes that people who buy potatoes also buy onions, and this is the primary reason. Therefore, by bunching them together, she makes it easy for the customers to choose both of them together. At the same time, she also increases her sales and performance. Now that we understood this particular story of the vegetable seller, let's start with the concept of a priori algorithm, which is almost similar to this scenario of the vegetable seller. A priori algorithm is a classic algorithm which is useful in mining frequent item sets and relevant association rules. Usually, you operate this algorithm on a database containing a large number of transactions. One such example is the items customers buy at a supermarket. Now it has got this odd name because it uses prior knowledge of frequent item set properties, and therefore the name a priori is derived from the word prior. Moving further, we'll talk about the theory involved in the a priori algorithm. There are three significant components which comprise this a priori algorithm. These are given by support, confidence, and lift. We will understand all these three in the further coming slides with the help of an example. Now the example says that let us suppose you have 2000 customer transactions in a supermarket. You are a supermarket owner and you have 2000 customer transactions. You have to find the support, confidence, and lift for two items, say bread and jam. It is because people frequently bundle these two items together. The given data says out of the 2000 transactions, 200 contains jam, whereas 300 contains bread. These 300 transactions include 100 that includes bread as well as jam. Using this data, we shall find out the support, confidence, and lift. Now, starting with the definition of what actually support means in the a priori algorithm. It is the default popularity of any item. Here, it is the jam. You calculate the support as a quotient of the division of the number of transactions containing that item by the total number of transactions. According to our example, the support of the item jam is given by transactions involving jam divided by the total number of customer transactions, which is given by, according to our example, 200 divided by 2000, which is equal to 10%. So therefore, this means that out of total number of products, 10% popularity is of the product jam. Moving further, we will talk about confidence. According to the example, confidence is the likelihood that customers bought both bread and jam together. Dividing the number of transactions that include both bread and jam by the total number of transactions will give the confidence figure. According to this definition, confidence is given by transactions involving both bread and jam divided by total transactions involving jam, which is given by 100 divided by 200 according to our example, which is equal to 50%. This implies that 50% of customers who bought jam bought bread as well. This is known as confidence. Moving further, we will talk about lift. According to our example, lift is the increase in the ratio of the sale of bread when you sell jam. The mathematical formula of lift is given below, which is equal to confidence for both jam and bread divided by the support of product jam. According to our example, it is given by 50 divided by 10, which is equal to 5. This says that the likelihood of a customer buying both jam and bread together is 5 times more than the chance of purchasing jam alone. If the left value is less than 1, it entails that the customer are unlikely to buy both the items together. Greater the value, the better is the combination. That means if the value of the left is less than 1, we cannot bundle up those items together. Now that we have understood the concept of a priori algorithm, let's discuss its pros and cons. When we say good things first, we will discuss pros first. It is easy to understand and implement, and this is the thing that I like about a priori algorithm. It can also be used on large item sets. Now that we have discussed pros, we'll discuss cons. At times you need a large number of candidate rules for this algorithm. It can become computationally expensive. It is also an expensive method to calculate support because the calculations has to go through the entire database, which is obviously time consuming. Now we'll discuss the limitations that the a priori algorithm has. This process can sometimes be very tedious. Moving further, we will discuss how can we improve the efficiency of the a priori algorithm. We can do this with two ways. The first one is the transaction reduction. A transaction not containing any frequent k item set becomes useless in subsequent scans. The second method is hash-based item set counting. It excludes the k item set whose corresponding hashing bucket count is less than the threshold in an infrequent item set. There are other methods as well, such as partitioning, sampling, and dynamic item set counting. At the end of the presentation, we will discuss what all things did we understand in this particular presentation. A priori is an algorithm for frequent item set mining and association rule learning over relational databases. This algorithm was introduced by R. Agrawal and R. Shrikant in 1994. It proceeds by identifying the frequent individual items in the database and extending them to larger and larger item sets as long as those items sets appear sufficiently often in the database. Thank you so much for listening so much patiently. Thank you.
If you liked our video and would like to recommend it to your friends, please like, share and subscribe to Indeed Inspiring Infotech. We would also love to hear your suggestions and feedback in the comment section below.